everyone. Assalamualaikum warahmatullahi wabarakatuh. My name is Muiz Aziz from Malaysian Refining Company, Sdn Berhad. I'm working in one of the Petronas refinery in Malacca as industrial hygienist. Looking at the topic, it is about how we manage the challenge of reducing the hazardous gas level in the form of benzene and mercury during the tank storage maintenance period. Study was done 4 years ago. So in refinery, we receive and refine crude oil from various locations from around the world. Majority are from Middle East. So this crude were transported through sea by oil tanker, also known as petroleum tanker. So a petroleum tanker or oil tanker is a ship designed for bulk transportation of oil and products. So there are two types of tankers: crude tankers and product tankers. Crude tankers carrying unrefined crude oil to our refinery, and product tankers carry refined products away from our refinery. So this shipment of unrefined crude was managed by another team, production planning team. So after the agreement on the quality and the price, so the unrefined crude oil will be transported to us as a customer. So there are very thin margin for time management throughout the process. So here comes the problem. Our crude storage tank has to undergo maintenance and inspection from time to time. One of the tedious part of the maintenance is sludge cleaning process. As you can see in this picture, that the sludge is the layer that form at the bottom of the tank. It has to be removed because it will consume the space inside the storage tank. If we leave it like that, the storage space will become smaller and smaller, and the maintenance will become more difficult, and it could possibly damage the tank. So the sludge was usually thick and hard and required a large numbers of workers to manually clean it. Commonly, there are about 50 to 60 persons working in 4 shifts on one tank with diameter of about 50 meters. So these workers has to enter the crude storage tank, which is a confined space, to clear out the sludge. So the sludge content itself gives more hazard to the working environment. There are two more commonly identified hazardous gas contained in the sludge, which were benzene and mercury, and the levels were far above permissible exposure limit, PL. The PL for benzene and mercury is 0.5 ppm and 0.025 milligram per meter cube respectively. So hence, the worker has to wear full PPE, the chemical suit, and the self-contained breathing apparatus, SCBA, and all of these impacting the time for the completion as well as cost of the project. So that causes delay to the maintenance, impacting the delivery of new incoming crude oil, which causing demurrage. So demurrage is the cost that our company has to pay due to the failure to load or discharge the ship within an agreed time period. So it charges per volume. So the bigger the ship, the bigger the charges. As per info provided by our business planning, 1 day delay cost us about 100,000 ringgit. Hence why we come up with this project. So to estimate the improvement target, we have identified the average time taken to reduce the hazardous gas to PEL. We have monitored the time taken on 5 tank cleaning activities. The average time taken was 32 days. So from a thorough analysis, discussion, agreement with our top management, we have set a target to reduce time taken by 2 days earlier, just 2 days. So what will happen if we manage to reduce the time taken by 2 days earlier? So the maintenance and the cleaning process can be done more efficient. Workers do not need to wear SCBA, which is more convenient to them, less risk, and the whole process can be more productive. So bear in mind that there are other projects done at the same time to reduce the tank maintenance time further, such as process improvement, crude selection studies, and etc. But we only focus on the industrial hygiene part. So to start, we have done the analysis using Ishikawa or fishbone diagram. So looking at the process, we're looking at the process, the human, the method, and the machine to identify the root causes of the delay. So we identified three main problems that we could improve from the process. So number one is the ventilation strategy. At that point of time, the ventilation was done just as per requirement. There was no proper ventilation plan available, which leads to inefficiency to remove the hazardous gas. So a crude storage tank normally has two main holes that will be opened during the maintenance activity. The blower was located at one side of the opening, but since the diameter was so big that the air that blew out from the other opening will only depends on the positive pressure inside the tank. This leads to the majority of the gas trapped inside the tank. So the second problem identified is the ventilator performance. Testing on 5 random blowers used at site found that the performance does not even achieve the minimum specification stated on the blower. We have done further studies on the 10 more blowers and we found the same problem. And the third causes identified was the slush cleaning technique. Manual cleaning clutch technique using shovel was observed with about 60 workers working in 4 shifts a day. The average sludge removal was about 90 to 100 drums a day. So with that, we have identified 3 solutions to improve the process, which are to prepare a ventilation plan for confined space, to verify the ventilator performance prior to start work, and to use more efficient slush cleaning technique. So for the first and the second solution, we do it at once since it was directly related. First, we prepare a draft of ventilation plan by understanding the tank dimension. We compile all the drawing for the crude storage tank. Then we develop a calculation for tank areas and volume for each tank. Also, inside the plan, we calculate the right numbers of ventilators required, and we draw where is the best position to put the ventilators and where the air will flow. So to put it simply, is that we add ventilator to another opening of the tank to suck out the air from the inside the tank. That adds the pulling pressure. Okay, at the same time, we replace the old underperforming ventilator with a new one. And as we can see, the performance were better with an improvement of about 5 to 10%. So we combine both improvement and do a comparison between tank cleaning without ventilation plan and with ventilation plan. We can see that without ventilation plan, the reduction of benzene is less than 5% and less than 10% for mercury. With ventilation plan, the removal for benzene was above 25% and close to 40% for mercury. So we take the improvement of about average about 30% in overall removal of the hazardous gas. So with that, we have established the ventilation plan strategy for all crude tank activity, incorporating all the input from the study. So next, for the third solution implementation, we have had a discussion with crude oil tank cleaning technical professional to come up with ideas. Among the ideas that were used were to use chemicals where the sludge production will be reduced. However, the team rejected the idea of introducing new chemical which could jeopardize the integrity of the internal part of the tank. There was also a suggestion to use automated system, which requires no workers to do the cleaning activity, which is good. However, the cost of the installation, the renovation required to the tank, plus the cost of the expert that required for the system maintenance was far, far beyond the ALAP approach. Hence, the team agreed to adopt the semi-automated system. With the semi-automated sludge extractor, there are only 1 workers needed to operate the equipment. As you can see, there are only 1 seat only on the equipment. Special features that was made available to the prototype was to have a shovel, knife, and a connection to the hopper. So the shovel will replace the manual worker's job. It will put the slush to the knife, which will grind the slush into smaller form. Then the prototype was also installed with vacuum system that will suck all the grounded slush into the hopper and directly go into the drum located outside of the tank. So we have conducted a 7-day test to compare between the manual semi-automated system, and we observed a 21% improvement in the slush removal activity. So by adopting all these three solution proposal, we have tested on 5 tank cleaning activity, and Alhamdulillah, we managed to achieve the average improvement in reduction of the hazardous gas during the tank cleaning activity from 32 days to 27 days. So as the conclusion, we have successfully achieved the target to improve the tank cleaning activity, not only in terms of reducing the time taken to reduce the hazardous gases, but also in terms of the productivity and safety risk. As we can see, small changes can make a huge improvement to the whole outcome. So to end this sharing, I will encourage everyone who have had good ideas in your mind, don't keep it to yourself. Your ideas might change the way we do our work better. With that, thank you.